Hello friends, we are in the sessions about the sensitive ground fault detection. We have discussed all about these methods in first 3 sessions, and we had separate 8 sessions about the first method and another 6 sessions about the second method. Now we are on the third method of this with angle between. This method is with angle between zero sequence voltage and zero sequence current. In first session, we have discussed all about the functional diagram orally, and right now in this session, we are going to discuss about this rotation angle, about the direction determination, about the direction determination method. To understand it better, let's have a point on in this part, that is the first method that we used. In the first method, we had here we had one reference voltage V0 as an axis on this we called as a real axis, and the current 3I0 was taking place during the fault, and we were providing an axis of symmetry, and we were projecting this 3I0 on that symmetrical axis, and the part that is the diagonal part on this symmetrical axis, we were taking this part for our direction determination. This part is decisive, we said. But in this method, we are taking V0 here as a reference voltage. Just previously we have drawn in a vertical manner. Now we are drawing in the as a horizontal manner. It doesn't matter. There's no difference between. Just it's for better understanding. We can draw it as a vertical. And here we have 3I0. 3I0 we have during the fault. But in this method, what we are doing, we are not providing any other axis. We are taking this V0 as an axis for determining the direction. Just we are trying to rotate this V0 according to our system configuration. We make it near to 3I0. We are trying to shift this V0 axis closer to 3I0 axis, to 3I0 diagram or vector, because we want this angle to be very small and our accuracy should be increased. So this V0 is called a V0 axis, but the second vector that we shifted, the shifted vector, it is called V0 rotated. This is our reference. The angle between the first V0 and the 3I0 was the phi minus. It's minus according to our system. We have drawn as a minus. We can draw it as a plus phi. And this angle that we rotated, the shifted angle, the tilted angle of the V0, we call it as a Q rotated, phi rotated, sorry, this phi rotated. And right now, to understand it better, we have V0 right here. We have V0 here, and 3I0 we have. Then we shifted, we tilted this V0, we rotated this V0 rotated. Now from this V0 rotated or V reference rotated, that rotation angle is phi rotated, of course. From this V0 rotated axis, that is our reference axis, from this axis we select an angle in the positive direction, in anti-clockwise direction and clockwise direction, as a positive and negative, which we call it as a phi, delta phi, that is around 88 in Siemens relay, 88 degrees. Around 88 degrees, and according to this new axis, we select the direction that even it is in this direction, so we call it as a forward. It means closer to V0 it is forward, and in opposite direction this direction is the reverse direction. So we select these directions we select as a forward. This side we select as a forward direction, and in opposite side we select as a negative as a reverse, backward direction. This is that guy only. This is our V0 that we take as a reference, and we rotate it, which we call it as a phi rotation. We have 3I0. This is the compensated value of 3I0, and minus, because we take this minus, as I said, that during the fault we have our 3I0 in the opposite direction of our phase current. This 3I0 is in opposite direction, and that's why we call it, we take it this minus, so that the relay can actually invert it and reverse the direction of this I0 and bring it to an angle with the V0 reference. Now we shifted this V0 reference as V0 reference rotated, and this is that angle only. Here we select this V0 as our axis, our reference axis, and according to our reference axis, in both sides of our reference axis, these two sides that we determine these sides with angle of minus delta phi and plus delta phi. These sides are called forward direction, and in opposite it is reverse direction. But here with this angle minus 1, this angle minus 1 becomes a little more this side, this side we call as a hysteresis range of plus 1. This is the hysteresis range. Is due to the operations and some errors on our VT and CTs, and VT of course. And here V delta plus this side. This area is called a hysteresis range area. This is the method that is we called that angle between 3I0 compensated and V reference, and we rotate this V reference angle according to our system configuration. It means we select this value of Q rotated value and rotation angle. We define it according to our system configuration. It can be it can be plus or minus 45, or it can be 90 degree. It can shift 90 degree in some cases. What we select these values, we will discuss later on how much it should be according to our system configuration. But in this session, we understood the V reference, we understood the 3I0 compensated value, and rotating our V reference closer to 3I0, and determining the forward and reverse direction, that how the relay determines the fault in forward direction to declare that this fault is in forward direction, and how it declares that it's in reverse direction. If this 3I0 is in this area, if 3I0 is in these areas, now our system will detect it as a forward direction. So in the second session, we discussed about the rotation angle and the forward and reverse direction. That is what the direction determination block does. This block, working of this block, we have explained in this session. Please help us providing you free learning sessions about relays and control protection, power system protection. And so please subscribe our channel and like the videos, share with your friends.